Hi there folks, my name is Max, and in this video I'm going to guide you through the exercise about the horizontal pipe in two different situations. At the top I have drawn this pipe with some key variables, length, diameter and the speed at which the liquid is flowing. And we're going to take a look at situation 1 and situation 2. And these are different situations. In 1 you have to calculate the pressure drop, and in 2 you have to calculate the velocity. To the right top I've drawn 3 different key methods how to determine the friction factor for F, and one is 46 over Reynolds, which we only use in the laminar flow region. We have 4F is 0.316 Reynolds to the power 1/4, which is the Blasius equation. And we can determine 4F by a graph, V/S Reynolds. And now we have to determine which way we are going to use for each of these situations. In both situations, I am going to start by using the Fenning equation that looks like this. If you want to derive this equation from the momentum balance, we have to take a look at the theory of this week. Situation 1 is a 0.1 diameter pipe in which a viscous oil is flowing, and the variables are all over there. Only one is missing, and it's the speed at which it's flowing, but we can determine this from the diameter and the flow rate, and it is 0.1 meter per second. Now, to determine which way we're going to calculate the friction factor, first let's take a look at the Reynolds number, which you can calculate with this equation. We have all the variables at the top, so the answer is 129. This means we're in the laminar flow regime, and therefore we may use 4F is 46 over Reynolds, so that is then 0.50. And we can just fill this in our Fenning equation and find the pressure drop, which is then 225 Pascal. Not much, but also the length of the pipe is not so much, so it is as expected. Let's take a look at situation 2, which is water. Therefore we have these two variables set. These were not given in the exercise, but you can look them up in, for example, a data companion or just on the internet. We have the relative roughness of 0.001, which accounts for little roughness on the side of the pipe. Now again, I have to use, not surprisingly, the Fenning equation, which looks exactly the same as in situation 1. But now we are looking for the velocity of the liquid, so I'm going to rewrite it into this form. It's just the same equation, but now written for the velocity. And again, I'm going to determine Reynolds. For we have to know it to decide how to determine the friction factor. And in this case, we can estimate that it's in the turbulent regime, since it is water and it's probably not flowing very slow. But also we have a relative roughness here. And we can only use the 4F versus the graph method to determine the velocities when not having a smooth pipe. The first two only account in smooth pipes. So we're going to use the graph. And for this I'm going to take a method which is called the iteration process. And I'm going to estimate a value of the velocity, and then I'm going to determine Reynolds determine the 4f, fills in the Venning equation, and redo this again. If we fill in this velocity in Reynolds, we find that Reynolds is 200,000. I can look this up in the graph, take the line for the relative roughness of 0.001 and find a friction factor for F is 0.022, which gives me a velocity, since I can fill this in the Venning equation, and I can find a velocity of 0.42 meter per second. Now I can redo these steps, right? So I can get a new Reynolds number, which is now 42,000, which is way lower. I can find a friction factor for this value, which is 0.025, and I can find a new velocity, which is then 0.4. And I have to do this over and over again until I find the same value twice. But finally I found in this exercise 0.39 meter per second. Your answer can be slightly different, since you have to read it from the graph and it is not that precise. But it should be around this value, between 0.3 and 0.5 meters per second. I hope you understood what I've done here and that you understood these two methods. And if you have any more questions, please feel free to ask us on the forum.